Hello everybody, welcome to another class. If we could start with some green checks, please, and then we'll get going. A little activity I want to do before we get into the meat and potatoes of today's stuff. I had an opportunity to mark, I think, all the learning guides for Unit 2 that had been submitted thus far. So if you have submitted that, just be patient with me. I'll get your password out to you hopefully before the end of the day. I noticed a couple of people had written the test and the marks look reasonable thus far, so that's good. And just remember that once you submit your learning guide, give me a bit of time, I'll mark it, and then I'll send the test password to your whatever parent email that I have in my file, and then they're going to supervise you in writing your test. Perfect. Jaden and Jonah, I don't have checks from you guys, but I think everyone's here in class today. That's nice to see. Excellent. Perfect. What I want to do is talk about the real number system, and this is actually in the notes, but I want to kind of get you guys to figure help me figure out the different categories of the real number system. So we're going to kind of come up with some definitions of the real number system. So all I want you guys to do is, in chat, I need you guys to write some numbers, and we're going to see if we can fill up the entire real number system with the numbers you give me. So I've got a diagram behind myself here, sort of different categories we're going to put the numbers into. We're going to try to define each of the circles of the real number system. I'm going to do my best to not mess it up as we go. But all I need from you guys are numbers. You can just put them in the chat. And as I see the numbers, I'm going to fill them into the real number system. And then we're going to see if we can come up with some rules as we kind of progress. 22 leads. I love it. All right, so 22, I'm going to put right there. 1646, 87, 1646, 87. All right, we got all those. 69 in there. All right. 99, that goes here. 72 also goes here. What are we thinking? Be a little bit more adventurous in our number choosing. 20,000, that's still here. I'm running out of room in the middle. Oh, Jesse, 3.1419. Is that supposed to be pi, Jesse? I can deal with pi. Pi. Brilliant. I'm going to put pi over here. That just got interesting. Why is pi over there? Leads, you're just trying to torture me here. I don't even know if I can write that in here. How many numbers of pi do I know? 3.14159. I think that's 5 decimal places. That's probably all I know. Let's see if I can get this right, Leads. 9,032,583. That goes there. All right. I think we've got the middle kind of sorted. Maybe somebody can think of some numbers that maybe don't fall into sort of the category of ones that we've had. We have pi up above me here. That was a bit different, so that one went there. 1. That goes in the middle as well. 11/8. Jesse. Bringing your A game today, Jesse. I like it. 11/8's over here. That's interesting. Numbers. Numbers you might have seen before. 6/9. All right, 6/9. I'm going to put that over here as well. It's going to go out in the outer ring. seen lots of different numbers. We've got that middle ring dialed, I think, with some numbers. 32 over 6, okay, that's going to go here. 32 over 6. 1.24 infinity leads. Oh boy, where would infinity go? You're going to really make me think now. Let's hold off on infinity because it's not really a number. 1.24 is going to be here. 3.333333333. It's going to go out there too. Leads you. We're going to have to hold off on infinity. Doesn't really fit for now. Maybe it does fit. I just don't know where to put it. You caught me on that one, leads. All right, we've got these kind of two other rings here that have nothing in them. We've got some stuff happening up above me here. We got that middle ring dialed. The outer ring's good. We got these two other rings here. Let's maybe dig a little deeper into the numbers that we can think of and come up with. We've got some patterns developing, I guess. There's numbers that we haven't come up with yet. Whole categories of numbers that we haven't come up with yet. You guys you'll get it eventually. 5.6. Oh boy. Jenna, I'm going to lose a few decimal places on that one. 5.6000. Let's go with that. And then 1.23, Jesse. 123.123. There we go. Negative 5.12. Oh boy, Eric. I love that you have the negative sign there, but it's not going to really enlighten us much. Negative 5.12. Jenna, that would go in the middle ring. I simply don't have any room for it in there. What is that's like 60 trillion, 785 billion. This is too long. Jesse, you have filled in the second ring with a 0. Well done, Jesse. We still have this third ring, and it's empty still. What do we think? Yeah, you deserves a big old boom, Jesse. Boom. All right. Jesse thought outside of the box a little bit. 0.2. That's going to go out here. Ian. Eric, you were onto something. But then you went and ruined it for me. I was so excited when I glanced up, I saw that, and I'm like, but I took it away. Very excited and very disappointed all at the same time. Oh, Eric, you read my mind. Negative 5. 0 over 5 is technically 0, so we'll just leave it in that second ring. And 5 over 0, you can't divide by 0, it's undefined. It's just impossible math operation. But Eric has this negative 5. And Eric, you and Jesse have filled in these two rings. So maybe let's see if we can get a few more numbers in this third ring. So Jonah, you have negative 10. I like it. That's going to go there. Jenna, killing me here. All right, I'm going to write it. I have room this time, Jenna. I got to take a step over to the side. Negative 500 billion 897,000 million 676. There it is, Jenna. And then leads with negative infinity. All right, negative 15, Jonah. Negative 20, negative 30, negative 100. I feel good about that third ring now. What about the one up here? We've got pi up there. We talked a little bit about these numbers last day. Can we think of some other numbers that can go up here? I feel like a Super Mario character. Bling, bling. He like hits the little coin. You guys are too young to even know what Super Mario is probably. If it weren't for like Smash Brothers, you guys would have no idea. Mario Kart. All right, I need a couple more up here, and then we're gonna start to figure out sort of classifications of these numbers. Make you think a little bit. Pi. What's special about pi? Oh, Eric, you've done it. Eric, you read my mind again. 9.652974028349287664. And Eric, what I'm going to do is, because I think I know what you're getting on about here, I'm just going to put some dots next to it because you didn't want that to terminate, did you? You wanted it to go on forever. All right, so that's there. Fair enough. Jesse, you've gone and done the same thing. So let's just go 6.8763, and that kind of just goes on forever. I like it. All right, there's one that we talked about last day, actually, that I like to put in this category because it's something we're going to talk about again today. And it's not, we talked about the difference between having an exact value and then, yeah, Joni, exactly. Any number that doesn't terminate is going to go in there. We talked a little bit about having an exact value and then like a representation of it or an estimation of it. You guys have given me these long decimals, which are estimations because we're going to we got to end it somewhere. But can we have an exact value? Maybe has a little, like I'm playing charades now. I'm going to put the square root of 2 in here. We talked about that one specifically last day. All right, we've got all of these filled out. I should mention that this second ring, this 0 is the only thing that goes in there. That's why I wasn't really looking for much more in that second ring. Yeah, Jonah, square root, brilliant. So not all square roots are going to go above my head here, but the square root of 2 happens to be an example of one of these. I don't want to give it away yet. All right, so looking at what we have here, in the middle, I have these numbers. Can anyone think of, I don't want to say it, I guess kind of a definition of what these numbers are going to be? How would we classify these numbers in the middle? What are we going to, I mean, it's kind of difficult to kind of put it in words without calling the middle circle what it is, but what's similar with all the things in the middle as opposed to the 0 or the third ring with the negative numbers in it? Whole numbers. It's interesting that you use that word because we're actually going to use whole numbers to define one of these rings, but it's not the inside ring. As funny as that may sound. Let's think about this for a second. You can think back, let's go back about 3,000 years. Oh, Jesse, I really like the way you've written that. Real world numbers, not real world numbers. This is where I was going with my story. If you think back about 3,000 years or so, maybe a little bit longer, I forget the exact date, but what would people use numbers for? Well, if I was a person, a peasant, 3,000 years ago, I would use numbers to count things. Maybe I have a herd of sheep. I would go 1, 2, 3, 4, 5. I would count my 5 sheep. That's what I would use numbers for. Maybe I would trade sheep for, some wheat or something like that. There were systems of measure and things like that. So we get this middle circle, and it's just numbers you kind of use to count with. So you can go 1, 2, 3, 4, 5. Then we go to the next circle out, and you'll notice 0 falls in here. And one thing that we kind of take for granted in our number system is that 0 hasn't always existed. If you go back a few thousand years, people had no idea, no representation of the concept of 0. It wasn't, I wish I looked up the date, now I feel silly. Maybe somebody can look up when 0 was first used in the number system. But the idea of nothing is kind of an abstract idea. It's not like a concrete thing, like I have 5 sheep in my field. The idea of 0, if you didn't have anything, what's the point of counting 0? So 0 showed up on the scene a little bit later. And then the next ring has all these negative numbers in it. Does anybody remember what the negative numbers are called, and positive, but they don't have any decimals? They have a name. Does anybody remember what that name is? And then you'll notice the outer ring has some fractions. It has decimals, but the decimals don't terminate. They're all, the decimals do terminate. They all end. And they don't go on forever. That's kind of reserved for these guys over here. These guys are all decimals that continue on forever. And we had a fancy name for those guys as well. So some of you would use some words that we're going to use again, like Eric used whole numbers, and then Jesse used the real world numbers and not real world numbers. And that's a great way to define the difference between that inner circle and then the second circle there. So what I want to do is we'll jump into the bottom of lesson 1 from last day. Did we? We did that. I'm pretty sure we did this. And then I was talking about your calculator. Yeah. All right. That's where we left off. Here we go. So this is out of your notes. This is called the real number system. And there's real numbers and then there's imaginary numbers. So everything we deal with in Math 10 will be real numbers, and then we'll deal with imaginary stuff in grade 11, 12, and then further on. I know it sounds kind of funny, imaginary numbers. All right. Thank you, Jesse. So 1740 BC is when 0 became a number. So I said 3,000 years ago, so I wasn't too far off, maybe a couple hundred years. Okay, maybe 1,000 years or so. 1740 BC. That is when 0 became an actual number. So the idea of 0 is really recent in terms of human history. I mean, we've been around for a while, but we haven't always used 0 in our number system, which is kind of a interesting idea, I think. So this is the same diagram. The inner circle is something we call natural numbers. And natural numbers are things we can count. So we can put a value on 5 sheep, 1,000,000 grains of sand. Those are natural numbers. The next one out is the word that Eric used. This is why I kind of hesitated to use it. The next ring are called whole numbers, and they include 0. I'm going to write that in here. So 0 wasn't always a number. Now, if you haven't kind of figured it out, and you probably have, why haven't I drawn all of these circles independent of each other? Why don't I have natural numbers, whole numbers, blah, blah? Why haven't I drawn these circles all separately? Well, the circles include the inner circle. So what do I mean by that? If we kind of ignore these circles, you don't have to write this, but if you ignore these outermost rings and all we had was these 2 circles on the inside, all of our natural numbers are whole numbers. So 1, 2, 3, 4, 5, 6, 7. Those are all whole numbers. The difference between natural numbers and whole numbers is that all of the natural numbers are whole numbers, except 0 is now included in the whole number system. So natural numbers are whole numbers. All of the natural numbers are included in whole numbers. The word I was looking for the next one, remember this is the one where we started to include negative numbers, negative values. Does anyone remember what we call positive values and negative values? If I had like 1 or -3 or -7. Remember what these are called? I could put, 2 could go here if I really wanted it to. I bet you guys are going to remember it as soon as I say it. These are called integers. So integers are whole numbers. They can be positive or negative, and they include 0. So what makes integers special? They have sort of negative values are included in here. All right, so we have natural numbers are the ones we count with. Then we take the next step out. We get to whole numbers, which just includes 0. Then we get to integers. So up to this point, we haven't talked about decimal values yet. Once we get past integers, integers are whole numbers that are either positive or negative. That's why we have a special classification, because we include the negatives. If we get out a little bit further, we call these rational numbers. And rational numbers include things that aren't integers. So if we went back, you'd see these were a bunch of decimals, like 0.25. Hoping for red here, 0.25, 57, whatever. -8.43. Those are our rational numbers. So these are things that have a decimal. They can be positive or negative, a decimal, but the decimal has to terminate. And then outside, I'm not sure why it isn't included in this diagram, so we're going to draw another circle just over here. Everything that's not able to fit into one of the classifications in these circles, we call these irrational numbers. And irrational numbers are things like pi, the square root of 2, 1.72395, continuing on forever. Okay, so that's the real number system. Every number that we have that's real, it can fit into one of these circles. Now, the real number system gets really tricky because if I ask you to identify what category a number falls into, it can fall into more than one category. For instance, if I said classify the number 7, and I said, where would 7 go in this diagram? What type of number is 7? Well, 7's a natural number. 7 is also a whole number. 7 is also an integer. Seven is also rational. So 7 is all of those things. Because the 7 is in this, technically it would be the most inclusive category would be here. It's in this circle, it's in this circle, it's in this circle, it's in this circle. So it is all of those things. It's a natural number, it's a whole number, it's an integer, it's natural. I can get a little bit, I guess, trickier. If I said now -7, well, that's not a natural number, so I could get rid of that. As soon as I add a negative in there, it's not a natural number, it's not a whole number. It is an integer, because integers include the negatives, and it is a rational number. So -7 is an integer and a rational number. So if I wanted -7, I could put it right here, which is in this category, and the next ring out. So hopefully you kind of get where I'm going with this. The numbers are included in every ring that's like inside. We'll look at these more. All right, I wanted to get that out of the way. Before I go any further, does anyone have any questions from Unit 2? Now, I know we've kind of moved on from Unit 2, but I just wanted to make sure there was nothing pressing, nothing kind of holding you back before we continue on with this. So anything from Unit 2 that I didn't cover, something from the learning guide, something you're confused about, and I would love to do that for you now. Negative? Negative? Positive? I see Madison's typing. I might just give you a second, Madison, before we go on to the next one. Now, Madison, I've seen you, we've met a few times at the field trips last year. Yeah, no worries, Madison. I completely understand. Just do what you can. Is it Madison or Maddie? Do you care? Some people have a preference. I don't want to call you Maddie and then have you say, Mr. Borden, only my mother calls me Maddie, or something like that. Just want to make sure I get it right. Sometimes students write in their first names, usually Maddie. Perfect, thanks. And then because your name is Madison, you write it in because it's kind of formal to type it into Blackboard, but then you really always go by Maddie, so I'll probably just call you Maddie. It's just a little bit easier, and I'm lazy. 2 syllables better than 3. All right, use a number line to order these numbers from least to greatest. We have a number line here for you. We need to kind of figure out where everything goes. So looking at them, like square root of 2, I know that's like 1.41, I think. But the cube root of negative 2, I have no idea what that is. A number multiplied by itself 3 times that gives us negative 2. It's going to be a decimal. It's irrational. The cube root of 6, again, it's going to be a decimal. Square root of 11, I don't know what that is. And the 4th root of 30, no idea. So what I'm going to do is I'm going to find out what the decimal values or the decimal approximations of each of these are. These are all irrational numbers. They don't have terminating decimals. And then once I've kind of figured out that, I can, label a number line with some values and see where I can fit things in. So maybe I'll just do this down below here. I'll take the square root of 2. I'll bring up my calculator here. I'm going to go square root of 2. That's 1.4142. Okay, 1.4142. All right, the cube root of negative 2. I have a cube root button. I'm going to use that right now. Cube root negative 2, negative 1.2599. All right. The cube root of 6. Shift, get this cube root button again, 6, 1.8171. The square root of 11. Square root of 9 is 3, so this is going to be probably a little bit more than 3. Square root of 16 is 4. So it's going to be 3 point something, I would imagine. Let's find out. Square root of 11, 3.3166. Happy with that. And last, I have the 4th root of 30. All right, so on my calculator, I go 4, then I have to go shift, x in front of it, 4th root, and then 30. And I hit enter. And I get 2.3403. All right. So I need to put these things on my number line. I've written down approximations for each of them, but we want kind of exact things on our number line. So what I'm going to do is I'm going to find the smallest and I'm going to find the largest, and then I'm going to kind of label my number line from there. So if I look, let's see if I can find the smallest. 1.4, I have negative 1.2. I think that's the only negative one I have, so this is going to be my smallest. And then my largest, I have the square root of 11 is 3. So this guy is my largest. Why do I care what my smallest and my largest are? Well, I want to use a number line that includes all my values. So over here I'm going to have a negative 1 somewhere, and over here I'm probably going to have a 3 somewhere. So I bet if I go by 0.5s, everything will kind of work out. So let's call this negative 1, negative 0.5, 0, then 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4. That should be good. So that gives me everything from my negatives to my positives. I got my smallest to largest. Now I just need to kind of find where things go. So the first one here, I have the square root of 2 is 1.41. So this is 1.5. Just before 1.5 is going to be 1.4. And that's where the square root of 2 is going to be found. The next one I have is negative 1.25. So that's going to be about here. There's negative 1. So this is the cube root of negative 2. This is my second one. The cube root of 6 is 1.8. All right, so it's going to be probably just before 2. This is the cube root of 6. Next, I have 3.3166 for the square root of 11. There's 3.5. 3.3 is going to be just before that. Square root of 11. And then the fourth root of 30 is 2.3. It's going to be in here. And there we go. We've gotten all of our numbers on our number line. So you'll notice in the course that this sort of process is going to happen a bunch. In the practice, you'll encounter it as well. The idea here being that when I take the square root of 2, it's an irrational number. The decimal is going to continue on forever. But if I write something like 1.41, that's an approximation for it. So if I want to put it on a number line, I'm going to have to approximate it to figure out kind of where it goes, and then I can just put the square root of 2. Same idea with pi. If I was asked to put pi on here, I could do that. Pi I know is 3.1459. If I wanted to put pi, I'd find 3.1, which is going to be about here. I could put pi there. It's fine. There's nothing wrong with that. It's an approximation. That's about where it's going to go. That's the idea here. So there you go. Exact values, approximations, irrational numbers. Is that it? Did I miss a page? We're done. Whew. Doing okay today. All right, so that's kind of it for lesson 1. Why don't we jump into the learning guide here for a second? I think I have a bunch of solutions in here that I don't want. All right, so in the learning guide, remember, maybe I'll take a double step back here. In the course, we have Unit 1. We kind of started in Unit 2, now we're back to Unit 1. There was 2 things at the top. Unit 1 learning guide, I need to put the 1 in there still. And then Unit 1 lessons. We're going to go through these lessons together. I'm going to have you guys go through the learning guide on your own. that makes any sense. So we kind of just finished lesson 1. Normally I'll finish a class on the end of a lesson. We're kind of caught mid-lesson. But anyways, so usually what I'll do is I'll say, okay, that's lesson 1, and then I'll look at the learning guide. So let's look at the learning guide, and we'll see what the learning guide has. So the number system, we talked about the real number system. We have natural numbers, whole numbers, integers, rationals, and irrationals. Those are all represented here. And then it asks you to identify each of the following numbers. So remember that these numbers can have more than one classification. When we have something like -7, well, that's a rational number as well as being an integer. So be careful when you're labeling these, because there's going to be more than one label for a lot of them. Some of them are tricky. And then it kind of gets into list any of the numbers that are terminate, repeat, are all integers, natural numbers, explain, just kind of gets into some questions. And then some number lines, just putting the decimals on number lines, or taking the square roots of numbers and figuring out what their approximation is, put those on the number line. And that kind of is where we left off. So there's sort of 2 pages of questions for you guys to do there. What I'm going to do is, because we still have lots of time left, I'm going to jump into the second lesson, and we'll look at a few of these questions, and then we'll see where we end up. It is 11 right now, so we have about 20 or 30 minutes left. This is evaluating irrational numbers. So not all of these are going to be irrational at first, but I have this chart at the top because I'm always amazed at students' ability to remember these types of things. So when you guys are in grade like 4 or 5, you start doing times tables, and we kind of, math teachers drill it into you, like, you must know what 5 times 6 is. And it just kind of helps, you know, you do your math. If you know your times tables, it's just speedier. We have calculators now, and you guys all have a calculator. And if you have a cell phone, you really are just walking around with a calculator in your pocket. But if you're at a restaurant and you have, like, I don't know, trying to figure out the bill, and there's 3 of you and you all ordered a pop, and there was, you know, $5 per pop. It's nice to know what 3 times 5 is, to know how much you're going to have to pay. I don't know. That's why it's important to know your multiplication tables. Just like right now, you're going to learn your perfect squares and your perfect cubes and a couple of perfect fourths. And I'm not going to insist you memorize them. If you were to memorize them, you would do a lot better. Not better in terms of like a mark, but everything would just come a little bit easier for you. So we're going to look at what the perfect squares are. So the idea here is that if I had 1, and I had 1 times 1, or 1 squared, 1 times 1 is still 1. If I went 2 times 2, I'd have 4. 3 times 3 is 9. 16, 25, 36, 49, 64, 81, 100, 121, and 144. These are our perfect squares. So you should know your perfect squares from 1 to 12. 13 squared and 14 squared do come up from time to time. So, I don't know, 13 times 13 is 169, I think. Yeah. If you want, you could write 169 for 13 over here. The more of these you know, like know, not just kind of can recognize, but like just know. I know that 9 squared is 81. I know that 12 squared is 144. The faster these things are gonna come for you. So there you go. The square root of 1 is 1, and the square root of 4 is 2, and the square root of 9 is 3. Now, I'm not entirely sure why I included this line, but I did. So we'll just get over it and we'll just move on. All right, so there's my perfect squares. Now you do my perfect cubes. A lot of students know their perfect squares, but the perfect cubes comes a little bit more challenging because you don't really deal with it a lot before grade 10, but you will deal with it a lot once you're in grade 10. A lot. So it's important to know these, like know them inside and out. All right, so perfect cubes. 1 times 1 times 1 is 1. There we go. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 is 16 times 4 is 64. 125. And that's usually where I kind of draw a blank. So I know the first 5. 6 times 6 times 6, I'm going to do that one on my calculator. It's 216. I never remember that one. And let's go to 7 times 7 times 7. 7 cubed is 343. Now, generally speaking, the numbers that you will encounter in Math 10 aren't going to be big. Like, rarely will you run into 216 or 343. Those aren't going to happen very often, but they do happen from time to time. So if you knew up to 125, the first 5 perfect cubes, you would be doing good. So know them inside and out. 8, 27, 64, 125. Those are your perfect cubes. The 216, 343, I never remember those. If a question runs into those, I'll just write it down. The cube root of 1 is just still 1. The cube root of 8 is 2. 3, the cube root of 64 is 4. 5, 6, 7. There we go. Perfect fourths. I don't know these at all. They don't come up very often, but I suppose you should know them. 1 times 1 times 1 times 1 is 1. This is going to be 16. 27 times 3, what's that going to give me? It's 81. Probably could have figured that one out. The fourth root of 1 is still 1. Fourth root of 16 is 2. And the fourth root of 81 is 3. All right. What is important here? You should know probably up to there, there, and there. These are the most commonly encountered ones that you are going to run into in Math 10. If you know them, like you know your multiplication tables, this stuff will just be pretty straightforward. And it's not like you need to sit there and memorize them. You're going to encounter them time in, time out, time again, and again, and again, and again. But now you have this chart, which you can refer back to. So if you're doing some problems, not today, but maybe next day, you can just look back at the chart and say, oh, the third root of, or 64 is 4 cubed, or yeah, 4 cubed. And you'll just know them. So let's look at, I guess, kind of estimating square roots. If we scroll down a little bit. All right, so for the first part here, which 2 perfect squares or higher power, some of them have more than square root, but what 2 perfect squares does the number fall between? So the square root of 13 isn't a perfect square, but it falls between 2 different perfect squares. So the perfect squares, when I'm talking about perfect squares, I'm talking about these guys here, the second row. So 13 isn't a perfect square. 16 is a perfect square. 25 is a perfect square. 9 is a perfect square. But 13 falls kind of in between these 2. So the square root of 13 falls in between the square root of 9. I'll just write it right in front of it, and the square root of 16. Those are the 2 perfect squares on either side of 13. Now I know what the square root of 9 is. That's 3. And the square root of 16 is 4. Now if I wanted to estimate the square root of 13, knowing that it's between 3 and 4, what would I estimate it to be? There's no right answer in an estimation, just, well, what is it closer to? 13 is about 3 numbers, it's not about, it is 3 numbers away from 16, and it's 4 numbers away from 9. So it's likely to be just a bit bigger than 3.5. If I were to estimate it, I'd maybe estimate it at about 3.6. If I want to really check in my calculator, if I'm really interested to figure out what it is, square root of 13 is 3.6055. So my estimation was pretty good, 3.6. All right, 28. What is 28 between? Well, 28 is between 25 and 36. And I know the square root of 25 gives me 5, and the square root of 36 gives me 6. And 28 is a little bit closer to 25 than it is 36. So I would probably estimate the square root of 28 to be, I don't know, maybe 5.2. Do we want to check? I kind of want to check. Here we go. Square root. I lost my square root button. Where is it? Square root of 28. 5.29. I put 5.2. It was probably 5.3. Would have been a better estimation, but it was my estimate, so it's okay. I'm happy with that. All right, 98 is between 81 and 100. Just put that negative sign out front. I would say the square root of 81 is going to be 9, and the square root of 100 is going to be 10. Does anyone want to estimate what the square root of 98 would be? I'd say 98 is probably a little bit closer to maybe 10. So it's probably high in the 9 5s, 6s, 7 8s. Sure. Jesse went with 9 5. Jonah went with 9 9. Let's split the difference. Let's go with 9.8. I'm not even going to check that one. All right, this 315 is a little bit tricky because I don't really know what perfect squares are up in the 300s. I mean, when I was doing this, I kind of quit at 169. So I might have to use my brain a little bit here instead of just looking in the chart above. 315. All right, if I went 20 times 20, that would be 400. Because 2 times 2 is 4, 20 times 20 is 400. So it's going to be maybe close to 20. I know this kind of defeats the purpose of estimating because I'm just going to use my calculator anyways, but I'm going to go 18 times 18 and see what that equals in my calculator. So if I went 18 times 18, sorry, I missed the 18 times 18. That's 324. All right, so that's just a little bit bigger. I'm going to put it just on the right. Square root of 320, stick with my color scheme here. Square root of 324 is 18. That means that whatever 17 is going to be on the other side. So 17 times 17 is 289. But Mr. Borden, why don't you just use the square root button on your calculator? Well, let's pretend I lost my scientific calculator and all I had was just a multiplication type calculator. 315 is a lot closer to 18. So if I were to estimate this, I would estimate this to probably be like 17.8 or something like that. Okay. So that gives us some square roots. Now we're going to get into a little bit higher roots, so cube roots and fourth roots. 81. Now this is where sometimes students get a little bit confused, but generally speaking, you guys can wrap your head around it at this point. But the square root of 81 is 9. What is the cube root of 81? Well, it's not a perfect cube. How do I know? Well, I just wrote down all my perfect cubes. And they're all in this column here. And you'll notice that this column, nowhere do I have an 81 written. So 81 is not a perfect cube. But 81 does fall kind of between 125 and 64. All right. So the cube root of 125 is 5, and the cube root of 64 is 8. 81 is about 20 away from 64, and it's about 40 away from 125. So it's going to be probably a little bit closer to the 8 than what did I write? 8. 4. Closer to 4 than it is to 5. I'm taking the square root in my brain. All right, so 81 is probably, I don't know, maybe 4.3. I'm going to check that one just to see how close I was. All right, cube root of 81. 4.32. I'm good. We're going to leave the cube root of -1 for now, so that we get into some troubles there. But let's do the fourth root of 50 and the third root of -72. I'll give you guys a second to do those. See if you can come up with an estimation for the fourth root of 50. Estimates. They don't have to be perfect. As close as you can get. And then the cube root of -72, that one's even trickier. If you can figure that one out, that'd be good. But we're just estimating. There's no right answer. Fourth roots. Might have to look up at my sheet here. Go. All right, if I get estimations for the fourth root of 50 and estimation for the cube root of 72 negative in chat, I will stop for the day. If I don't get any estimations for those, I'm just going to continue on. I'm going to finish off this whole page, maybe even the whole lesson. 2.7. I like that, Eric. It's a little bit closer to 50 is closer to 81, so I can handle that. 2.7. That looks good. And then 64 and 125. Just kind of ignore the negative for now, but We'll talk a little bit more about that later on. What is 72 closer to? 64 or 125? An estimate for that. Really? You guys just really want me to keep doing math? Oh, I was kind of excited to just call it a day. But if you guys want me to continue, 4.2, okay, that's better. All right, 4.2. Sure, a little bit closer to 4 than it is to 5. Completely acceptable estimates. All right, that kind of is a good place to stop, I think, without getting into too much of the remainder here. I just want to look at the learning guide and talk about the questions I'd like you guys to do for next day, and then I will... we'll just quit. Just quit. I know. Mr. Borden, you're such a quitter. All right. So we talked about the real number system today. We classified some numbers. There we go. We talked about number lines a little bit, so you should be able to do that. Difference between... We did estimates. Definitely just did estimates. So you guys should be good about that far. And that's it. So this is kind of where we'll end here in terms of questions. So this is on page 3. You should be able to do everything up to number 6 on page 3. So pages 1, pages 2, and up to number 6 on page 3. So that is what I would like you guys to do for next day's class. Now, I believe next week we only have one class because it's we have Thanksgiving on the weekend, and then we don't ever have class on Fridays. So that only leaves Tuesday, Wednesday, Thursday. I think we have one English, one math, and one ADC planning. So that gives you guys lots of time. Gives you about a week to get through some of this stuff. It's very, very important. I know most of you have finished all of the Unit 2 stuff, but I need you guys to get that test done. Remember, we're going to set out in terms, everything to page 3, number 6. So on page 3, Eric, we're going to do it starts at 1. Estimating radicals, you're good up to number 6. So essentially everything to the end of page 3. Except this evaluating irrationals. We haven't talked about evaluation yet. So that gives you, today's Thursday. I won't see you again for probably 4 or 5 days. Getting Unit 2 done is kind of priority numero uno. We have to send out interms next week, and it would be really great if you had a Unit 2 test on that interm, so I don't have to send to your parents a letter saying, hey, so-and-so hasn't done any of their Unit 2 stuff yet. They have a 0% in math right now. I don't want to send that out. So get your learning guide in. I'll get you some corrections and pointers sent back, give you the test password. And remember, tomorrow is Friday. I'm not in my office. I am at Rutland Senior in the morning, and then I'm at Central in the afternoon. So if you submit your learning guide tomorrow, I won't mark it because I'm not at my office. I'm doing things, learning. And then on the weekend, it's Thanksgiving. I'm going to be eating turkey from like Saturday morning till Monday evening. I won't have time to mark any math then. So if you want your learning guide to get marked and that test password before next week, you got to get that in today, before the end of the day. I'm usually out of here at about 3, which means if you hand it in at 2:30, that'll give me time to mark it and get it back to you. And I have class this afternoon, so it's tight at best. Anywho, I hope you guys have a terrific weekend. We don't have our regular field trip tomorrow, but you guys have kind of 4 days to hang out, enjoy time with your family, maybe eat some turkey if you're into that sort of thing. So have a great weekend, and we'll see you guys back next week. Thanks.